Okay, if you're not quite sure how to use the Venn diagrams, let's do this sheet together. All right, so first it says, number one, give the prime factorization of 40. Now, how do we find the prime factorization? We need to make factor trees. So let's quickly make a factor tree here of this. We make 40, split that into any factor pair of your choice. I'm going to do 5 and 8. 5 times 8. 5 is circled. 8 I'm going to split into 2 times 4. I have to keep going until everything is circled, right? 2 is a prime number. And 2 times 2. Okay, so I got prime factorization is, oops, sorry, go back, is 2 times 2 times 2 times 5. Notice I put them in order over here. I took the 2's first and then the 5. They have to be in order of least to greatest. Remember that? Okay, prime factorization of 32. Why don't you pause this while you go and figure that out on another place. So I'm going to wait while you pause. Okay, you're back. Hopefully you got this as your prime factorization. So what we're going to do is we're going to try and put both of these numbers down in this Venn diagram. So first I'm going to name each of these two circles. I can call them 32 and 40 because those are the numbers I'm working with. Now the order doesn't matter. Just to be clear, I could just as well have done 40 and 32. So I'm going to leave it this way just so I don't have to erase again. Now, let's look at what is the same in these two. We have 2 in both of them, another 2 in both of them, another 2 in both of them. So those 3 2's, that's what's in be put in the center here. 2 times 2 times 2. Right? And then what do I have left? In the 32, remember this over here was 32. There was 3 2's. There's still 2 more 2's. So I got to put 2 more 2's over here. And over here, 40, there's still a 5. So I have to put a 5 over here. Clear on that? Now I want to point out one important thing here. You notice that over in this part here where there's 2 2's, and over in this part here is a 5, there's nothing that's the same. That should always be true because anything that would be over here and over here should have been in the middle. So there should never be something that I find on both those spots, right? All right. What are the common factors of 32 and 40? We're not going to talk about that right now. That's for if we're working this out. But very quickly, oops, those numbers, I'm going to change back to blue. Those numbers would be 1, 2, 4, and 8. If we listed all the factors, we would figure that out. And we could see that all those are here. We can't see the 1, so they're in the middle because we can see here's 2 is just that, 4 is that, 8 is that, and except for 1, which is never listed. We have to remember that 1 is not listed, but it's always there. All right, what's the greatest common factor? The greatest common factor, that's the 8. And where is it seen? By multiplying all of this together. 2 times 2 times 2, which then we have to show the work. 4 times 2 equals 8. Least common multiple. That is where we find least common multiple is found by multiplying everything in the Venn diagram. In Venn diagram. Okay, that's the key idea. The greatest common factor is here in the center. The lowest common multiple, let's change color again. Lowest common multiple is everything multiplied together. I'm going to bring that over here. So what is the least common multiple? Least common multiple is 5 times 2 times 2 times 2 times 2 times 2. Do you see where I got those? 5 times 2 times 2 times 2 times 2 times 2. 5 times 2 times 2 times 2 times 2 times 2. Now I want to multiply them together. I'm just going to say, oh wait, I already know that 2 times 2 times 2 times 2, that's all this stuff. That's going to be 32. So I just have to do a 5, here's a 5, times all that 32, which equals 160. So that is the lowest common multiple of 32 and 40. And if I were to list multiples, that's the first time that I get something together. Okay? Let's do 18 and 81 now. The first thing I want you to do is first figure out the tree diagrams of 18 and 81, and so you end up with the prime factorizations. So figure that out, and then come on back to me with those prime factorizations. Pause now. Welcome back. You see I've put the prime factorizations here. Hopefully that's what you got. Okay, now we are going to make a Venn diagram. So I got to make these circles. Let me tell you, it's good to make a big part in the center here so you could fit them all in. We have to make our rectangle. We're going to name the two areas. We're going to call this 18 and this 81. All right, let's underline what's the same. See if you can find my error. I'm going to make an error on purpose here. Okay, 3 and 3 is the same, so I'm going to put a 3 here. 18, what's left? It's a 2 times 3. 81, what's left? 3 times 3 times 3. So 81, that should be 3 times 3 times 3 times 3. Hey, that's right. 18 is 2 times 3 times 3. That's right. Let's see if that makes sense. 2 times 3 is 6, times 3 is 18. Yes. 3 times 3 is 9, times 3 is 27, times 3 is 81. Yes. So where's my error? Very good. I hear you guys screaming at me. Mr. Lewis, you have a 3 outside both of here. I can't do that. That 3 should be in the middle. And you're absolutely right. Where did I go wrong? I didn't underline enough over here. You can see there's 2 3s in the middle. All right. So we're going to move on to the next page now. It says, using that Venn diagram, what's the greatest common factor? Well, we know that greatest common factor is whatever's in the middle here. So that equals this stuff here. 3 times 3 equals 9. 9 is the greatest common factor of 18 and 81. Next question asks, what's the least common multiple? That's going to be everything in here. So least common multiple is 2 times. Now I want you to first write it all out. And then you can say, okay, that's the same as 2 times all this is 81. It's great if you underline that like that. It makes it clear. And then I can multiply those. 162. 2 times 8 is 160. 2 times 80. And then the 2 times 2 is an extra 2. So the least common multiple of 18 and 81 should be 162. All right. I want you to go ahead. I want you to pause this and try and do 27 and 12. And then when you come back, press play and you will see my solutions. All right, press pause now. All right, here's the Venn diagram. After you figured out the prime factorizations, here's the Venn diagram. So the greatest common factor, what's in the middle? Oh, just a 3. Greatest common factor is just 3. Least common multiple of 27 and 12 is everything multiplied together. 3 times 3 times 3 times 2 times 2. That equals, that's a 27 times 2 times 2 is 4. 27 times 4 is 108. I can do that in my head, but if you can't, just multiply it to the side. All right. Why don't you do 16 and 27 next, and then check. Well, I'll have both the greatest common factor and the least common multiple figured out when you come back. So pause the Rooney right now. Uh-oh. Did you come into the problem I was hoping you'd realize? There's nothing to underline in my 16 and 27. So there's nothing to put in the middle. So over here I have all my 16. And over here I have all my 27. And there's nothing in the middle. What then is the greatest common factor? And that goes back to saying that we have to remember all the factors are listed except one. So that's the greatest common factor of 16 and 27. Least common multiple, in this case, is going to be whatever 16 times 27 equals, because that's all of those times all of those. And in this case, that turns out to be 432. You can multiply on the side to figure that out. Okay, the last problem, let's look at very quickly. I want you to find the prime factorizations of 24, 18, and 30 after you pause this and then come on back. Okay, pause and then come on back with those. Okay, you can see I've set these up here, and if you notice I set them up in the other form that we learned of lining up lowest common multiple, prime factorizations in order to find lowest common multiple and greatest common factor. That should help us understand how we can use a Venn diagram to do these. Remember, we organize it like this, and just as if there was two of them, the greatest common factor is going to be whatever's in both of them. Oh, in this case, there's a 2 and a 3. Actually, let me write them in their columns so we don't go back. Going down here, the greatest common factor is there's a 2 and there's a 3. Multiply them together. Greatest common factor is 6. Lowest common multiple will be everything, right? 2, bring that down. 2, 2, I'm off, moving off. 3, 3, 5. That's what this should turn out to be. Therefore, that's 2 times 2 is, see, can we break this up? We know that this is all 24. So 24 times 15 equals 360. Move that. That's the lowest common multiple. How do we use a Venn diagram for that? We're going to need 3 circles. See if this works out correctly. We've got 24 circle, 18 circle, and 30 circle. We need a box around them. And we're going to fill these in with the information we've got. What's in all 3 of these? I could kind of underline. It'd be a 2, 3. So we have that in the middle here. 2 times 3. Okay, is there anything that's in any of them that's repeated? No. There's nothing that's in both these two that's not somewhere else. So we put these 2 in here because there's nothing that's in the 24 and 30 that's left. 18 is left with just the 3. 30 is left with just the 5. Therefore, the GCF is what's in all 3 circles, 2 times 3. And the LCM is what's all in these together. And as you can see, it's the same numbers as here. 2 times 2 times 2 times 3 times 3 times 5. All right, that is the highest level of Venn diagram that I expect you to even be possibly able to think about, because a 4-circle Venn diagram is actually nearly impossible to draw. So if you understand this, amazing. What I really want you to be able to do is all the problems up through it until 18, all the 2 diagram circles. All right? So now please working on your homework. Good luck.